Okay, good evening everybody. Okay, I'm doing my second recording at home, okay, because we are having a HBL, home-based learning, which means everybody is locked down at home. We are not allowed to go to school. Okay, the good thing is at home, I have a quiet environment for my recording. Okay, and today we'll be doing at chapter 7, Kinetic Model of Matter. We will look at in details for solid, liquid, gas, different state of matter, what are their properties, and the forces, the molecular attractions between them. For the starter, we will be looking at the state of matters. What state of matter? Namely, solid, liquid, gas. The properties are roughly the same, and in fact, I would like to encourage the students to look at their chemistry textbook, okay, or their notes. They have actually a much better or much detailed explanation as compared to physics. My textbook, okay. It's usually found in the beginning chapter, maybe chapter 2 of the textbook, okay. Okay, so I will encourage you guys to go and read up, because the explanation is actually much clearer and simpler, okay. But in terms of content, they are actually both the same. We are talking about the properties of matter, whether they are fixed shapes or just high density, all this, okay. But bear in mind, in chemistry, for this particular topic, chemistry eventually will deal with different bonds, intermolecular bonds between the particles, namely ionic bond and covalent bonds, and in turn looking at the properties of the substances with certain particular bonds. Let's say ionic bonds will have certain properties, compound with covalent bonds will have certain properties. But in physics, we are not looking at the type of bonds. We are more focused at the other aspect, in the sense that with the bonds and with the particle, how do they interact with each other to give rise to the properties of different state of matter, okay. In that section, we usually term it as kinetic model of matter. Kinetic model of matter, in a nutshell, is actually looking at the particles. Actually, so the moment we see kinetic model, usually the answers of the theory involved is involving the molecules, the particles inside in the matter. Okay, to see how they interact to give rise to the properties or to give rise to certain behavior. Okay, solid, same thing. The basic definition that you have, basic properties that you're looking at. One thing to note is that in physics, we have this term called intermolecular force, or what we call attractive force. We avoid writing bonds because we are not looking at covalent bonds or ionic bonds, so we have a better term for it, which we for physics, which deal with forces. So we like to use this word intermolecular forces. So students, please bear in mind. Okay, this is what we call, in chemistry they will say the bonds, in physics we say intermolecular forces. Okay, and it's the strong intermolecular forces that give rise to the properties of solids, okay, and even liquid and gas. So for example, because I have very strong intermolecular forces, the particles are actually held together at fixed position. And because they are held together at fixed position, the volume of the solid is generally fixed, is fixed, and it has a fixed shape because they are being held together. And because of that, I actually have high number of molecules at a certain unit volume. More molecule means more mass. As a result, it will lead to solid having a high density, because density formula is mass over volume. Okay, because the particles are held together. So at any one instances, the amount of molecules inside this particular confined space is actually the maximum if you look at all the three states. And because I have a lot of particles in this fixed unit of volume, the mass actually will be the largest, and as a result, the density will actually be the largest. The same thing will work for a liquid, okay, whereby the intermolecular bonds or intermolecular forces are not so strong. They are still strong, but they are not very strong, and as a result, the particles are able to slide. They are still held together, relatively close together, but they are not the forces are not like superly strong. As a result, they are not fixed. They are still allowed to move across each other, and because they are able to do restricted movement, liquid are able to take up the shape of the container. Okay, they have no particular fixed shape, okay, but they have fixed volume. Okay, because the amount of matter, the amount of molecules that are still bounded together. Okay, and as a result, the density will be relatively higher, but it's not the highest. The highest will be the belonging to solid. So liquid will be like second tier. And the same thing will happen again to gases, okay, whereby the intermolecular forces are very weak and the particles are not strongly attracted to each other. They are far apart, very far apart, and they are moving at a high speed, and because of that, this particular state of matter, they do not possess fixed shape or fixed volume. Okay, and this is how properties of gases come about, because of inherently the nature of the intermolecular forces. Okay, now this is a classic example to illustrate the forces with relationship to the intermolecular distance between the particles and how they changes across the three states. Okay, it's a classic example. Everybody will have it. Okay, likewise for chemistry. Okay, now the new thing that we have here in particularly is Brownian motion. Okay, what is Brownian motion? Brownian motion actually refer to the behavior, okay, of the observer behavior of certain particles and how it's being theorized to how the explanation actually leads to the discovery of random of the air molecules or small particles moving randomly in the environment. Okay, for Brownian motion, okay, if you look at it, there are actually two parts in this Brownian motion. There's one part where we look at the observer, the observations, and the other part we look at is the explanation. Okay, one thing to highlight to students is that if you look at the explanation, okay, for observation and explanation, there are actually two characters involved. Okay, the first one that we're looking at is the particle. Here I will term it as the big size particle. Okay, the big size particle. Okay, in the classic example, it will be smoke particle. Then they will be suspended in air. Okay, and we have the second character, the air, which is the small size particle. Usually, I will deal with the small size particle when in the explanation. So, how does Brownian motion works? Okay, Brownian motion inherently talk about what is being observed first. It's being observed that the big particle, when suspended in air, he will actually make random motion. Okay, he will move randomly. Okay, and the reason behind this random motion is actually the existence of small particles in air bombarding the big particle. So what actually happens is this, that when the big size particle is suspended in air, he is actually surrounded by a small particle, the air particle. Okay, so what we have is we are looking at the it could be the classic example of smoke particles suspended in air, or we have another classic example whereby we have a water pollen suspended in water, and the small particle we are looking at in this case will be fluid particles or water molecules. So end of the day is depending on the example they are quoting. So let's say I use smoke particles. Okay, so the small size particle here we're looking at will be the air particle. Okay, so the small size one will be air. The big size one will be the smoke particles. So what actually happens is that the small size particles are actually colliding with the big size particle. And this random bombardment will actually give rise to a net force. Okay, being exerted on the big particle. Example, I have a big particle. Okay, then after that it's being bombarded in all directions, and the net force will cause this particle to move in a certain direction, random. Okay, so let's say move this direction, and again the small size particle is bombarding the big size particle again, and there will be a net force, and this net force will push the big size particle again in another direction. So all these are being done simultaneously at different instants of time, and the net force is actually giving rise to what we call a random direction or random motion. Okay, so if you look at Brownian motion, it's actually talking about how this big size particle move randomly, and the reason behind is actually the existence or the bombardment of the small particles. Okay, and this is what Brownian motion is about. Inherently, there are two characters inside these explanations, and this Brownian is actually important because the observations, big size particle moving randomly, actually tell us, or actually allow us to infer the existence or the behavior of the small size particle, namely the air molecules or the water molecules. Okay, and with that, the same theory, okay, you will find that the same behavior if I change the condition, example, the smoke particle is suspended in air again, the random motion again, but now what happened is I have temperature involved. Okay, so I increase the temperature. You'll find that, okay, what we have is with more energy, which is the temperature, what they are doing, the conservation of energy, the thermal energy is converted to where? Kinetic energy, which is why the kinetic energy increases. And with higher energy, the particle is actually able to move at a faster speed. So what we have is we have temperature increases, we give rise to increase in motion, and that motion actually give rise to increase in bombardment. And because of this increment in bombardment, the net force exerted will be larger and it will change rapidly much faster, and the smoke particle, which is the big size guy, okay, will actually move faster and change direction more frequently. So which means the direction, the movement will be more chaotic in this case. Okay, so this is what we have for Brownian motion with a certain twist in it, with a certain change in the condition. Okay, but the fundamental concept about bombardment by small particle and net force being exerted is actually the same. It still remains the same. Okay. Okay, so here I have a classic example. You can read it on your own. Okay, whereby I deal with particles. How do I explain the density of the smoke particle? Namely, same thing, I look at the mass and I look at the volume. But in this case, I don't look at it in terms of kg. I look at the mass as in terms of the number of particles. Because remember, we are using kinetic theory of matter. Your answer has to deal with particle. Okay, so it has to deal with molecules. So we are looking at high mass. Why high mass? Because I have high number of particle inside. Comparison, or the assumption is that I compare across a fixed volume. Okay, so I have a fixed volume, I have a fixed mass, I deduce the mass, and because of the density, mass per unit time, mass per unit volume, I am able to deduce that the density of the solid is actually much higher. Okay, here I like to highlight one thing. If you look at the explanation of the of density, the explanation actually follows strictly or follow closely to the formula. Okay, so how do I look at it? I need to explain density, I need to first highlight to the marker what is the mass in terms of particle. I need to highlight to the marker about the volume. Okay, equal volume here. And before I conclude about the density, I need to tell the marker what is the formula here. Okay, what is the formula? And how do I tell them? Is I use the standard phrase with mass per unit volume, which is telling the marker I'm looking at mass divided by volume. I'm not looking at mass plus volume or mass times volume. Okay, so if you look at the keyword, if you look at the formula, it's actually the keywords actually follow quite strictly with the formula. I give the mass, I give the volume, and I must state the formula. Okay, but of course I have certain ways of stating it, which is mass per unit volume. After that, then I give the conclusion about what happened to the density. So it will be mass, volume, formula, followed by the final outcome. Okay, so when you talk about explanation, it's actually quite related to your mathematics, because the keyword actually comes from your mathematical formula. Okay, just that we need to know, or students need to know how we are using it. Okay, with this, okay, I come to the end of this particular topic. Okay, any questions? Okay, for this particular topic, you can just drop me an email. Okay, if you would like to know more updates about my videos, or to get updates about the latest video I'm making, okay, click the link at the bottom. Okay, subscribe to my video, okay, to my channel for the latest update. Okay, thank you very much. Okay, and see you.